Your applications are some of your organization's most valuable assets. Today, you will learn about securing your applications and business in the digital economy because application security is business security. Good morning, I am Maricris Carandang, F5 Business Development Manager, and with me today are Farsh Mijares, our F5 Product Manager, and our F5 Solutions Engineers, Ralph Alzaga and Jay Carries Lime. Be prepared to have a complete grasp of who F5 is and how our solutions can protect your applications from today's advanced attacks and tomorrow's emerging threats.
F5 is a global company that specializes in application services and application delivery networking. Its technologies focus on the delivery, security, performance, and availability of web applications, including the availability of computing, storage, and network resources. F5's offering was originally based on a load balancing product but has since expanded to include acceleration, application security, and DDoS defense. Applications are mission critical assets for every organization, and our goal is to help organizations stay productive and competitive with F5's trusted solutions for ensuring seamless and secure application performance in any environment or infrastructure.
In the current cybersecurity landscape, hackers use smartphones, tablets, and many devices included in the Internet of Things or IoT. This is a way to spread malware. Web applications are then exposed in the Internet. E-commerce platforms are widely used for digital and contactless payment and transactions, including shopping, logistics, food ordering, banking, and many more. These devices don't have security included in the hardware or software. All too often, security for these devices is ignored, either by not adding security tools or not creating security policies to cover the devices. So, how can one protect an organization's network and data? Good cybersecurity begins with an understanding of how to recognize security threats and the steps to take to avoid them. Understanding the cybersecurity landscape helps you to see what types of threats are presenting the most risk today and how that will evolve into the risk of tomorrow.
Some of today's application threats and challenges are OWASP Top 10, open source libraries, bots and malicious automation, and distributed denial of service or DDoS.
Attacks nowadays have gone beyond network, and hackers have realized how applications are more important to enterprises in an app economy world. So here are some of the most common challenges and threats facing modern applications today. The OWASP Top 10 is probably the most well-known resource covering risks to web applications. The list is compiled based on what a consensus of security professionals identifies as the most critical risks to web applications. Another one is open source libraries. In the age of agile application development, most applications are built using open source code and frameworks. This obviously lets developers avoid inventing the wheel with each application and leads to faster, easier development. The downside is that when a new vulnerability is discovered, the issue can apply to every application that uses the code, instantly exploring hundreds of thousands of applications across the internet. And once those vulnerabilities are known, organizations are in a race to try and patch their apps before attackers can automatically scan and exploit them. In addition to traditional vulnerabilities and attacks, applications are increasingly facing a wave of malicious automation. These threats often use automated bots to attack an application on a large scale. To make things even trickier, many automated attacks don't target a vulnerability per se, but instead leverage valid application features in an unexpected way. Lastly, DDoS or the distributed denial of service. We must also consider attacks that simply want to bring down public access to the application. These attacks can rely on a wide variety of amplification techniques to drive massive amounts of traffic to a target application. Layer 7 DDoS can acquire an application to perform a large amount of work for a small request.
So, how can we help you? A web application firewall or a WAF protects the web applications from a variety of application layer attacks, such as the OWASP Top 10. These are cross-site scripting or XSS, SQL injection, and cookie poisoning, among others. Attacks to apps are the leading cause of breaches. They are the gateway to your valuable data. Some may already have IPS, IDS, and standard firewalls in their network to prevent these types of attacks. Unfortunately, those appliances will not be able to prevent XSS attacks, SQL injection, or web session hijacking if your web applications are vulnerable to those kinds of attacks. In order to adequately protect web servers and applications, therefore, you should consider adding a specialized web application firewalls to your network. With the right WAF in place, you can block the array of attacks that aim to exfiltrate that data by compromising your systems. A WAF protects your web apps by filtering, monitoring, and blocking any malicious HTTPS traffic traveling from the web application and prevents any unauthorized data from leaving the app. It does this by adhering to a set of policies to help determine what traffic is malicious and what traffic is safe. Just as a proxy server acts as intermediary to protect the identity of a client, a WAF operates in a similar fashion, but in the reverse, called a reverse proxy, acting as an intermediary that protects the web app server from a potentially malicious client.
First, let me walk you through with our test setup. This consists of our client that will serve as our attacker on the external network, and the DVWA web server as our test server on an internal network. Then F5 sits in front of our test server, functioning as a full proxy device, bridging the two networks. And by the power of full proxy of F5 gives you a full control between the client side and the server side data traffic, applying the different traffic management rules and policies, including your application security policy for web application protection. For F5 configuration, we need to define the local traffic objects, the network, and the security policy to be used. F5 system, to note, is a default deny device, meaning it will only accept traffic if it is configured to do so. And in order for F5 to process the data traffic, it needs to have certain local traffic objects. And these are your nodes, pool members, pools, and the virtual servers. Nodes are basically objects which represents the real servers or hosts on the network, which in our case, the DVWA web server. Pool members are the nodes with an associated service port to listen to. In this case, we have DVWA server and 443 service port. Pools are very similar to server farm or cluster. It is a logical object that contains one or more pool members. And virtual servers, on the other hand, are made up of a virtual IP address and a service port that F5 listens to and receives traffic on. So how your configuration for virtual server to listen really depends on how your application is running and what requirements you have. For the networks, we need to define the default route, the F5 interface IP addresses or self-IPs, and VLANs for the external and internal networks. And certainly, we will apply security policy for web application firewall on our virtual server to mitigate the attacks. We already pre-configured F5 with the local traffic objects, network, and the security policy, initially in transparent mode so that we can observe that no requests are blocked altogether by the policy, and for us to watch what violations it catches so we can have the control to revise as needed and change to blocking mode. So in this demo, we will illustrate how F5 can help you mitigate and provide you a comprehensive report on 2 of the top 10 OWASP attacks and 2 of the most common threats in web applications. Now, let's take a look on the actual configuration and testing. Logging on now to our F5, it is important to note that you must assign a strong password to your management access. Now, checking all the configurations as defined in our topology, we have our nodes, our DBWA server at 10.1.20.17, and our pool configured with the member DBWA server listening at service port 443. And this pool is assigned to our virtual server, the DBWA CS. The destination address is 10.1.10.6, and the service port listens to is the port 443. For the network settings, we have configured, of course, both external and internal VLANs. Associated to it are F5's interface IPs, or what they call as self IPs, for both external and internal VLANs, together with our default route and default tree. And lastly, we have our application security policy for web application firewall assigned to our DBWA virtual server. And as detailed, we initially set the enforcement mode to transparent for us to see the violations F5 catches and that such requests are not yet blocked. Now, checking on F5 security event logs, you can see that no records or requests to display yet. Now, time to initiate an attack, and let's start first with the SQL injection attack. Logging into our vulnerable web application server, let's initiate SQL injection attack. And SQL injection attack is a technique often used to attack data-driven applications. This is done by including portions of SQL statements in an entry field in an attempt to get the website to pass a newly formed rogue SQL command to the attacker's database. And SQL injection is a code injection technique that exploits a security vulnerability in an application's software. And this vulnerability happens when the user input is either incorrectly filtered for strings embedded in SQL statements, or if the user's input is not strongly typed and unexpectedly executed. So now let's do basic injection onto our vulnerable web application and check if F5 would be able to detect the attack. Okay, so first, let's start by inputting any number to the text box, and the expected web page value is supposed to print an ID, the first name and the last name to the screen. So below is the PHP select statement that we will be exploiting, specifically the ID or the user ID. Now, let's change or inject an SQL attack by inputting a string of commands, like for the percentage apostrophe to identify the false values, and the 0 equal to 0 string for all the records that are true. So in this scenario, we are saying to display all records that are false and all records that are true. And percentage apostrophe string will probably not be equal to anything and will be equal to the false value, while apostrophe 0, apostrophe equal to apostrophe 0 is equal to true value because 0 will always be equal to 0. So the database statement selects the first name and the last name from users where the user ID is identified as either false or true. Okay. So now we have injected an SQL, and let's see if F5 has been able to detect the attack. So refreshing the event logs, we should be seeing the attack we initiated right there. So as you can see, F5 has detected the signature, and checking on the details, we can see that the attack type is identified as SQL injection, and with all the details, it shows a comprehensive information, not just on the attack signature type, but also the source IP, the destination IP, the host, the client, the virtual server affected, the security policy involved, and the enforcement action, which is by this time is transparent, so there's none, and even the geolocation where this attack is coming from, and also if the identified source IP is included in the database of intelligence IP known as a bad actor. So certainly there are a lot of information that you can check on F5 once it detects the attack. So the request status is flagged as illegal since this policy is still transparent. Now let's do another popular OWASP attack, which is known as the cross-site scripting. Cross-site scripting is a type of computer security vulnerability typically found in web applications. And cross-site scripting enables attackers to inject client-side scripts into web pages viewed by other users, and a cross-site scripting vulnerability may be used by attackers to bypass access controls such as the same hardening policy. The victim's browser has no way to know or identify that the script should not be trusted, and it will execute the script because it thinks that the script came from a trusted source, and the malicious script can access any cookies, session tokens, or other sensitive information retained by the browser and used in that site. Alright, so let's now test a basic cross-site scripting attack, and again check if F5 would be able to identify the attack signature. So with our vulnerable web application server, let's name this as our launch attack, and let's type it alert message of this is an ENPH F5 cross-site scripting exploit attack test. And message. And signed guestbook. So as you can see, our cross-site script has been triggered. So this is an ENPH F5 cross-site scripting exploit attack test. And let's see if F5 has been able to capture the attack alongside with our SQL injection. So refreshing the event logs, we have right there. So we have cross-site scripting attack detected by F5. So similar to SQL injection, checking all the details, we can see that the attack type is a cross-site scripting, which was initiated to our vulnerable web application, and this request status is still illegal or flag as illegal because of the transparent mode. And together with the SQL injection, we can have a ton of information related to where the attack is coming from and what attack type it is. Okay, so now let us block these attacks, and we can do that by changing the policy enforcement to policy blocking mode and apply the policy to our concerned virtual server. So going to our application security policies and clicking on the policy, changing the enforcement mode to blocking mode, and we save it and apply the policy. Checking back the policy. Now from transparent, it is now in blocking enforcement mode. Let's go back and initiate again the attacks and check if F5 would be able to block the attack. So for SQL injection, let's type again our string and submit. Now, as you can see, the requested URL was rejected. So that means F5 has blocked the SQL injection attack. And then next, for our cross-site scripting, let's launch an attack similar to what we've done earlier to sign a guest. And as you can see, we have the requested URL be rejected. Now, checking on the event logs, let's see if both attacks are logged and can be seen as blocked. Right there. So you can see that both SQL injection attacks and cross-site scripting attacks are now have been blocked. So checking out the details, we can see that the enforcement action is blocking and the request status now is blocked. Similar with SQL injection, enforcement action now is blocking and the request status now is blocked. Okay, so with all the information gathered by F5, we can easily identify what the attack signature is and where it is coming from. I hope I have shared a part of security features of F5 Web Application Firewall by demonstrating to you how we block SQL injection and cross-site scripting, two of the top 10 OWASP attacks and two of the most common web application threats. So with F5 Web Application Firewall, you can take advantage of applications and data protection from known and unknown threats, including defense against bots that bypass standard protections and virtually patches application vulnerabilities. F5 is continuously geared to the advancement in the WAF space by including comprehensive bot mitigation for web and mobile applications, credential protection in the browser, and automated behavioral analytics using machine learning.
So here's a summary and some key takeaways during this session. So why do organizations need a WAF? Today, enterprises are extending their businesses by using web-based and cloud-based cloud-hosted applications. So having a robust and agile web application firewall in place to protect them from security threats isn't a luxury. It's a necessity. At the same time, organizations must meet stringent compliance requirements for online commerce, protect business-critical web applications from common attacks such as DDoS and zero-day attacks, and enable secure data sharing across traditional and cloud environments. With F5 Web Application Firewall, you can take advantage of apps and data protection from known and unknown threats, defense against bots that bypass standard protections, and virtually patches application vulnerabilities. A more active approach to security that will help organizations put in place an effective control and comprehensive protection of their web applications. To know more about F5 Web Application Firewall solution, reach us at the contact details on your screen and we would be glad to do a demo for you. Protect your data and your business. Think up security first. Thank you, and we hope that everyone stays safe and healthy. Grasp of who F5 is in terms of application security. Manager, and with me today are Ferrell Marsh Mijares, F5 Product Manager, and Ryan. Ralph! My goodness!
First, let me walk you through with our test setup. Ay nako.
Some may already have IPS, IDS, and standard firewall. Ugh.